Welcome to Weka tutorial. In this tutorial, I'm going to show you how you can achieve the results of every fold in a k-fold cross-validation setup. You can go back to my tutorial 12 where I used the experimenter tool of Weka, the Weka GUI, instead of Weka API to get the results, especially precision, recall, F-score, and error rates of every fold in a k-fold cross-validation environment. So for this tutorial, I have written a class called Weka test, and this Weka test has one single method called main. Now I will go through every line of this main method and illustrate what that line actually is doing. The very first line creates an object of instances class. The name of the object is also instances. What this means is I'm using the buffer reader to read the file called 2.rf, and the structure of the 2.rf file is explicitly mentioned in my previous tutorial. So this line here is actually taking every instance of 2.rf file in the instances object. Now we will move to the second line. In the second line, what I'm doing is exactly what I did in my previous tutorial. In this line, I am actually setting the class attribute that denotes the positive and negative labels of your dataset. So I am calling the method called setClassIndex of object instances. This method actually sets the class attribute of your dataset. And if you can recall, the class attribute of 2.rf file that I'm currently using is situated at the very end of the attribute section. So if my dataset has 10 attributes numbered from 0 to 9, then the class attribute is going to be 9. That's why I have deduced 1 from the number of attributes method return. Thereafter, I have declared 4 double type of variables: precision, recall, fmeasure, and error. Also, I have assigned them 0. Then I have number of variables declared again. The first one is called size. The size is defined as follows. I have called the method num instances of instances object and divide that by 10. So the size integer variable is actually the size of every fold. For example, if I have 40 instances in my dataset, then the size is going to be 40 divided by 10 equals to 4. This means we have 4 instances per fold. Variables begin and end are declared to control the test instances. So the begin is set to 0 and end is set to size -1. So if you can recall from your machine learning old school book, in a 10-fold cross-validation setup, if we have 40 instances in our dataset, then we have fold 1 containing 0, 1, 2, 3, fold 2 containing 4, 5, 6, and 7th instance, and fold 10 will contain 36, 37, 38, and 39th instance. So as we set begin to 0, that means fold 1 and end set to size -1, that's 3. So that means fold 1 is going to be our test set for the first iteration. Then we have a for loop. This for loop is actually taking control of all the folds. We have 10 folds, that's why the loop starts from 1 and ends at 10. I am also printing the iteration number at the very first line of the loop. Then I am creating instances object. The first one is called training instances, and to create that instances object, I am giving all the instances in my dataset. In the third line of this loop, I am creating a testing instances object. So in order to do that, we have simply modified the argument list than that of training instances. In this time, we are sending the instances, all the instances in our dataset. We are also sending the begin and end minus begin as our argument. This means that this line states that create a training instance with all the instances of our dataset, but the test instance should contain only those instances from begin to end minus begin. And also, from a tenfold cross-validation setup, you should remember that the test set should be excluded from the training set. That's why we are deleting those entries from the training instances that are inside the test set. Then I'm creating a naive Bayes object. That's my classifier called tree. And I'm sending all my training instances to develop or induce a naive Bayes classifier on them. I am also again creating evaluation object of evaluation class. This time I'm sending the testing instances because I am going to apply the naive Bayes classifier on the test set. That's why to evaluate model, I am just sending the classifier we just developed here and the testing instances. And afterwards, with this evaluation object, I'm printing PRF and E of this particular iteration. Next, I am just adding up the PRF and E because I'm just adding up for iteration 1, iteration 2 up to iteration 3 all the PRF and E, and then I will divide each of them by 10 to get the average PRF and E. The PRF and E, after summing up, dividing by 10, if we get them, then that's my average PRF and E for tenfold cross-validation setup. So in the end, we have numbers of operation. The first one is begin equal to n plus 1. Again, if we consider the example we have just seen, then our fold 1 contains 0, 1, 2, 3. Fold 2 contains 4, 5, 6, and 7th instance. And our fold 10 is going to contain 35, 36, 37, 38, and 39th instance. So for the next iteration, for the first iteration, for example, fold 1 was our test set. So the begin was set to 0 and the end was set to 3. For the next iteration, fold 2 is going to be our test set and the rests are going to be our training set. So we are setting begin to n plus 1. That means we will have a begin equal to 3 plus 1, that equals to 4. And we are also saying that end is going to be end plus size. So our current end is going to be, our current end is 3 and we are adding the size with it. So the size is going to be 4 and our next end is 7. Also, for the last iteration, we have to be careful. As we approach to the last iteration, if I equals to 9, at that time we don't have to add end with the size. Instead, we can easily call the num instances method and set that to end. That means in our very last iteration, our end is going to be set at 39 if we consider our data set to be composed of 40 instances. So in the very end, we are approached to the very end of the program. We have accumulated PRF and E for every fault, and we just divide them by 10, each of them by 10, to get the average precision, average recall, average F measure, and average error. So if we run the program and take a look at the output, then we can see that we have the results for every iteration. So you can see that this is the result for iteration 1, this is for iteration 2, for 3, and this goes up to iteration 10. So now you're having PRF and E for every iteration. And in the end, you can always see that we are having the average precision recall and F score, the accumulated precision recall F score and error rate, and we divide that by 10. So I hope that helps. See you in a week.